So these are just some interesting topics that I found from The Selfish Gene by Richard Dawkins. The first topic that I'm going to discuss is our selfish genes and why they are selfish. This was kind of over the entirety of the book, considering it was called The Selfish Gene. So why are genes exactly selfish? Well, they need to survive in a competitive world. So the predominant genes are going to be selfish. I'm going to give them personality. Say if you had a nice gene that was going around and just giving up their spot in line or whatever, at McDonald's, to all the selfish genes who just took advantage of this, then those nice genes, eventually, they would go extinct, because the selfish genes, because it's their nature, they're selfish, are going to try and take advantage of this. And so the nice genes are going extinct, which is why genes are predominantly selfish. So an altruistic entity is something that's the opposite of selfishness. It's an entity that behaves in such a way as to increase the welfare of another at the expense of its own. So, for example, if I were walking down the street and saw someone walking into the path of a car, an altruistic act would be to push them out of the way, saving them, but thus putting myself into the path of the car and risking my own life. A selfish act would be if a car was coming towards me and, in my panic, I push someone else in front of the moving car in order to escape. That would be a little selfish. But selfishness is natural. That's in our genes. Altruism is a learned behavior by humans, because we look down on selfishness. I'm not saying that we should go push people in the paths of cars, but I'm just saying it's not natural. Altruism is learned. We know it's better, but it's also not natural. There is one scenario in which genes are altruistic. For instance, if you had you and 10 other people all together in a room, and you were the only 11 people in the world that carried an extremely rare gene, so most likely you're all related. And, there's a poorly drawn bomb in that room as well, and you're all locked in there. Then, if you are the one in purple, if you could stop the bomb and save the other 10 people, but end up dying yourself, then the genes would want you to do this. Because if everyone in the room dies, they would go extinct. So they have two options. You and the bomb die, but there's these 10 other people that carry the gene. That's okay. They want that. Because the other option, you would all just basically die. They don't want that, because then their gene goes extinct and everyone blows up. So why are genes selfish? I know I kind of talked about this before, but there's another reason. So group extinction is extremely slow. Unless you're like the dinosaurs and a meteor comes and kills you all in one fatal blow. It's a slow process. However, individual competition is extremely fast. I mean, from the world today, it's a fast world out there. So, to them, selfishness equals survival and prosperity. If they're selfish now, they themselves are going to survive and prosper, even though it may hurt the group in the long run. But they don't look that far ahead. They don't say, if I do this now, then in the 500 years from now, my group is going to go extinct. That's not what they think. They think, if I do this now, then I'm going to survive and I'm going to prosper. It's kind of just like how humans are. Also, evolution is actually not for the species. I was a little surprised by this when I first read it, but then I thought about it. Evolution is not for the species because it's for the individual. That made sense to me after I thought about it. Because if you have a gene that separates you from the rest of your species, and it's to your advantage, then do you think, oh, I'm going to use this gene to reproduce and evolve my species? You don't think that. You think, I'm going to use this gene to my advantage to prosper and to be better than my species. The reproducing just comes along with it. And if that advantage is a true advantage, then you're going to survive, and your children are going to survive, and the children of those children, if they all have this gene, are going to survive. And eventually it's just that gene will evolve the species. But they don't think of it like that. Also, genes don't like evolution because they become extinct, some at least, when evolution occurs. They try their best to stop it. So an example of this, because I know this may be a little bit confusing, is, I'm drawing, that is going to be a terribly drawn tree. But if you live in a society with all herbivores, and for some reason you only eat the leaves off of the top of this tree that's really far up, and you are all these really short people with really short legs, then that's not going to fare well. Because, I don't know, apparently you haven't built ladders or anything and you just can't reach the top of the tree. But if a mutated gene comes along, which is the red guy on your, I don't know which way it is for you, it's on my right. If a mutated gene comes along and it has these really, really long legs, then they're going to survive better than you will. Just because they have really long legs and it's easier for them to reach the top of trees. They're going to use this to their advantage. But the gene for the short legs is not going to like this and will try its best to stop the long legs from becoming the norm and evolving the species. Because if the long legs come into effect, then the short legs genes is going to become extinct. And no one really wants to become extinct. So what is a gene? And why did I not explain this first? Well, a gene is any portion of chromosomal material that potentially lasts for enough generations to become a unit of natural selection, or to serve as a unit of natural selection. So this is your gene, that's your centromere. I had to draw that in. And then that little part right there, that's a gene. It's a little part on a chromosome. I probably drew it a little bit too big. So that's just a gene. So traits are made up of several genes, not just one. They are also interdependent. So a single trait would be like blonde hair or long legs. Those are made up of several genes. But these genes are interdependent. Now, what does that mean? That means that if they were in the presence of one gene, they might act a certain way. But in the presence of a different gene, they may act a different way. So, for instance, you may act one way around your friends, but there's no way in heck you'd ever act that way around your parents. It's kind of like that. So, wait. Why gene and not gene complex? Gene is a singular term. But if they're so interdependent, then why isn't it called a gene complex? Well, an individual, such as a human like you and me, is a temporary vehicle for short-lived gene combinations. Normally, they last 75 to 80 years, average. This doesn't occur in bacteria because they replicate all their genes, binary fission and such, and thus the parent is exactly identical to the daughter. When humans and other animals reproduce, however, there's a new combination of genes made. So that certain combination will only last for as long as you last. Because if you reproduce, then your son or daughter is not going to have the exact same genes as you do. The chances of your gene combination ever coming together again in that exact same combination is probably not going to happen. So when we die, that specific combination of genes dies along with us. But the genes themselves, the individual genes, have the potential to live on for generations. So that gene that acted one way in your body could act a different way in your children or your grandchildren's body. So even though they're interdependent, they are also very singular. So as I said, the combos may be short-lived, but the genes themselves are long-lived. So for instance, if your father has blue eyes and your mother has green eyes, you could either have just blue or green eyes, but these genes could also split up when they produce you, and you get a little bit from both. So, I mean, ideally you might have, like, blue and green eyes, but this was the picture I could find that most described this, most easily described this. So now you are also a cat. Why do we die? This was a topic that was brought up that I was, we all know people die. I admit I never really thought about this before. I know that we do die. Everyone knows that. It's a fact of life. But why? Why is there old age? Why do our bodies fail? I know that it happens. We all know that happens. But why? So the first one is the accumulation of errors. Like in cells, apoptosis and DNA polymerase, they try, but apparently not hard enough. So stuff happens, and the accumulation of these errors is thought to be a reason why people's bodies fail, and consequently they die. Now when I read that, I was kind of like, well, that was kind of obvious. But there's also a second theory that I liked. I don't know, it's a harsh way to think about it, an act of altruism, which is Sir Peter Medawwar's theory. He says that old individuals die as an act of altruism to the rest of the species, because if they stayed around when they were too decrepit to reproduce, they would clutter up the world to no good purpose, which is a very harsh way to put it. But I kind of like this theory. I know no one really wants to die, nor do they want the people they love to die, but the theory does have a point. It's not saying that the people themselves die on purpose. Rather, the genes have them die on purpose in order for the rest of the population to be able to survive. If the world got too cluttered, we would have no room, no resources, and then we would all die. So I think this theory is kind of positive in a way, because they're dying for the good of the species and as an act of altruism to us. So as awful as it is, and I hate to say it this way, but it kind of puts a silver lining on the matter that they're doing this for us. And that is all, folks. The end. And thank you.